Hi, I'm Jan Ozer. I'm meeting today with Yang Cai, CEO and co-founder of VisualOn, and we're here to discuss the VisualOn Optimizer, which uses AI to cut bandwidth by up to 70% with no impact on quality. Thanks for joining me, Jan.
Pleasure to be here with you.
So tell me about the VisualOn Optimizer. What does it do? How does it work with existing encoders? Things like that.
Okay, so VisualOn Optimizer is what we call an AI-enhanced universal content adaptive encoding solution. So it's not an encoder by itself, but it works with the encoder. So basically how it works is that it analyzes the content before or in parallel with the transcoder, and then adjusts the encoder parameters to achieve the target quality with the minimum number of bits. So it's very flexible and it's widely applicable because it's not tied to any specific encoders. And it's also agnostic to compression formats. We already support like H.264, HEVC, AV1, etc. And it works with both software and hardware encoders. We have integrate with many encoders out there. So, for example, the X264, X265, of course, with the FMPEG ecosystems, but also with the NVIDIA encoders for both for all the formats that they support, X264, HEVC, and AV1. We also have integrated with SVT AV1 from Intel and Netflix, and as well as a hardware codec from that team.
Okay. What's the bold claim you're making in terms of bandwidth savings? Is it the 70% that I talked about?
Yeah, so by nature, the result is really content dependent. If the content is easy to encode, then we achieve a lot of reduction in bit rates. But the most in reduction is probably not as important as on average. So on average, we're able to achieve like over 40 or 50% of reduction. So for example, with a customer integral, on production, they measure the bit rate reductions is over 54%. And
Okay.
that's on top of also improving in other KPIs like startup time and also buffering ratio.
Okay. And is that going to be the same for any of the codecs that you mentioned, or is it more for H.264 than AV1?
I would say it varies. So this is mostly for H.264, but the benchmark result has been quite consistent over the percentage of reduction is pretty consistent over different compression formats.
Okay. And how do you price the technology?
So we like to position us as cost saving instead of a additional cost item to companies. So basically, what we like is that if we can help customer achieve certain savings, whether from the bandwidth or storage, we try to get a percentage of the savings that customer can achieve. And we will be very flexible in terms of how we structure this with the customers.
Okay. Now, did the optimizer exist before you integrated it with AI, or did it start with AI in it?
So we have this technology before AI. So AI is something that we added on to enhance the results. So really, this is a combination of a long, decade-long deep knowledge in compression as well as the new AI technologies.
Okay. And tell me about the effort to add AI to the optimizer. How long did it take? How many videos were involved? How much training? Tell me about that process.
Yes. So Optimize is designed to be a practical and efficient implementation. So we want it to be able to deploy in all different kind of environments and application use cases. So we cannot afford to support a very large AI models. What we do is we have built a very smart AI model, and I think we train with a few thousands of clips. So what AI really apply in this case is that we use it to categorize the contents. And then based on the categorization, we fine tune the encoder parameters.
Okay. Is that dynamic over the duration of the video? I mean, does that occur frame by frame, or is that
Yes,
once?
yes. That's very important actually. It's dynamical. So the encoder that we work with has to be able to support dynamical configuration. That means we need to be able to change the certain encoder parameter on the fly, on a frame by frame basis.
Okay, so you're actually changing. Is it bitrate the only parameter that you're adjusting, or are you adjusting any other parameters in this dynamic encoding approach?
So optimize is what we call encode for quality. Instead of trying to reach a target bitrate, we try to reach a target quality, and we measure it by VMAP scores, but it could be other measures as well. VMAP just we find out is the best for us for now, and we adapt only a few high-level encoder parameters. One of them, for example, with X264 is the CIF value. So if some encoder doesn't support CIF mode encoding, then we can try to adjust the bitrate instead. For example, with the NVIDIA encoders.
Okay. So what was the efficiency you were able to achieve without AI, and how much additional efficiency did AI enable in your product?
So we were able to achieve the bitrate reduction or to improve the compression efficiency, mainly because it's content dependent. It's also for us, it's on the frame level. So even for the same content, certain parts might be more difficult than others to encode. We just basically allocate the bits more efficiently. So it end up reducing the bits a lot on the easier to encode parts, but also improve the quality of the more challenging parts of the video contents. And for AI, it's additional improvement in terms of quality improvement as well as the bandwidth reduction. We estimate about maybe on top of the other algorithms about 5 to 10% improvement.
Okay. And you touched on this a moment ago. I just want to dig a little bit deeper. When you talk about the AI training, what did that look like? I mean, I guess we're all familiar with how VMAP was trained, right? I mean, you get a bunch of scores, you get subjective MOS ratings, you compare the two, you learn, sometimes you're accurate, sometimes you're not, and you improve. Tell me about the process of using AI to make the optimizer better at reducing the bit rate without impacting subjective quality.
Yes. So for us, we mainly use VMAP as the measure because we cannot use a subjective measure to train to adapt or adjust the encoder parameters. And we use what we measure is we train the model and then we look at the encoded results at the end, the VMAP scores and the bit rates. And we find out that actually it converts very quickly. So after a few thousand trainings, the rate of improvement is not very significant or obvious at all. So for us, instead of trying to push to the limit for what AI can do, we try to allow some margin on the quality side. So for example, we typically set the target VMAX score to 96, which is very high, I mean, way above a perceptible level. So even if there's some errors, like if for some content, VMAX is not maybe the perfect measure, but we allow the marginal error to make sure that there's not going to be a significant quality issues.
Okay, what happens if I test with PSNR or SSIM? What would the savings look like under those metrics?
So again, it depends, and depends on because the optimize is very flexible. That you can choose to the trade-offs between, for example, computation time, compression ratio, or quality. And there are pre-processings that you can apply either using ours or your own pre-processing steps. So it all depends. We're experiencing with using PixSNR as a measure instead of VMAT. That would be much more efficient. But the problem is PSNR is very inconsistent. So even if you come up with good good, then the actual visual quality may not be good. And we don't find such a problem with VMAT, at least so far.
Okay. I guess my question is, if I tested some clips and achieved a 70% bitrate reduction with VMAF, what would PSNR look like using the same, the same clip? So you're using the same parameters. Would it just be variable, or would it be, 50% or 90%, or you just don't have experience? A lot of people don't trust VMAF. It's pretty easy to hack, and there's even the anti-hacking VMAF negative metric that you can use. So I'm just trying to understand how your technology is rated using other metrics like PSNR and SSIM and even MSSSIM.
I think we did some experiments on the SSIM part. We're probably about the same. With the bitrate reduction, the SSIM result coming out about the same. PSNR, it varies. Sometimes we're higher, sometimes we're lower.
Okay. When you talk about the 70% with VMAF, is that, I'm sure those are internal numbers. Do you have any external verifications?
So like I say, we have results from actual customer production. So this is measured through the through the actual production, not the benchmarking.
Okay.
And I mentioned that on average is over 54% in bitrate reduction.
Okay. And who were those customers? That particular customer?
Yes, it's Integral. Co-Integral is basically the digital media arm of Saudi television in Dubai.
Okay. So how does the optimizer integrate with an encoder?
So for now, we mainly going through the FMPEG APIs, and most of the encoder has taken on APIs. So for us, the integration is pretty straightforward. But for some third-party proprietary encoders, we do need the encoders collaboration to do the integration.
Most of the large-scale transcoders are FFmpeg compatible, certainly. What about a product like the AWS Elemental Media Converter or Media Live? I don't think those are FFmpeg based. Can you integrate with a product if it doesn't have an FFmpeg structure that you can attach to?
Yes, we certainly can. So the interface actually is very simple. We only have a few parameters to set. So the only thing we need to have is to have access to the encoder's API. And
Okay.
the other more important factor is actually that the encoder need to support dynamic configuration.
Is that a relatively common feature, or is that unusual for encoders to have?
I think it's very common. It's just that some of the encoders might not expose it to the outside. For example, you can try it out on the AWS Elementals on their website, and they don't open those APIs.
Okay. What's the density like? I mean, I used to work with NET, and I know that a single card can deliver, 32 1080p streams. What do I need to use the optimizer if I wanted to optimize all of those individual streams? And that's just for one card, and I can put up to 10 cards in the system. So what's it look like in a really large-scale transcoding situation?
Yes, that's a very good question. So optimizer software solution, it does require CPU available. But our implementation is actually very efficient. So in the worst case, I think we're less than 50% of the encoder itself. And in many cases, it actually run faster because we reduce the encoder speed rate. So it end up the whole process is faster. But for hardware encoder, we cannot quite scale up with Lightning kind of scalability yet. So for example, when we integrate with Lightning, we're able to run on the, I forgot the exact configuration of the server, but we're able to run about 10 streams simultaneously.
Okay. So that's something people who are considering your technology and need to think about. Have you noticed any difference? I mean, NVIDIA just has, I think they tend to produce lower streams per card, and I'm not familiar with any of the other ASIC-based transcoders. Are you seeing that as a limitation for any large-scale transcoding hardware, or just something you've experienced with NetEnt?
So yeah, it's just something that we experienced that And for if it's purely ASIC-based transcoding, we probably will need more CPU resources. So we need more server to support that kind of dynamic streams.
What are you actually doing to the video? Content adaptive, as most people know, it really just adjusts the bit rate up and down depending on complexity. You're not really changing any other encoding centers and encoding parameters. You're a pre-processing technology, so you're changing the pixels somehow before you send them into the encoder. Can you talk at a high level about what you're actually trying to do or what you're actually doing to the pixels?
Yeah, so the pre-processing part is optional. So you don't have to use us, or you can use your own. But we do have a pre-processing that's depending on content as well. So we adjust the pre-processing parameter depending on each frame that we are looking at. And in general, we don't try to mess with the source content. We're not trying to improve the quality of the source content. We're just trying to get the encoder to encode better.
Let me understand this. So are you pre-processing the pixels in any way, or are you just gauging how hard they are to encode and changing the encoding parameters?
So we can do both, but the changing the pixel part is optional. You can turn it off. The main part is really estimate the complexity and then adjust the encoder.
So of the customers who are using your technology, how many of them opt to, I guess, improve or change the pixels? Is that something most of them use, or very few, or how do they approach that?
I would say most of them using our default settings, but some of the customers they might change it without telling us how they exactly configure the parameters. Because our SDK is very, very simple to integrate. So some of the customers will just get our SDK and integrate on their own, and then they run production. We once as customer did it in less than 1 week.
Do you call those two different things? Do you have different names for those?
No, it's just the same technology or the same solutions. We do
So,
have, we do have a different skill or separate skill for particular use cases. For example, for the massive mesh files. So for those cases, we need to really preserve the quality and also the fidelity to the original content. So we have fine-tune adjust the parameters just for those cases.
what do you call the quality improvement component of the optimizer?
We don't really call it separacy. So it's the whole thing integrate together as a solution, and there are options the customer can choose to adjust. So they can choose whether to do pre-processing or not, or how strong, what's the strength they want to do pre-processing, that kind of thing.
Does pre-processing improve the compression efficiency, or is it just an appearance thing?
I would say in general, it improves the compression efficiency as well as the video quality as well.
Okay, but then you run into the whole creative intent issue, and
exactly. So that's why we leave it as optional, so the customer can do what they prefer, and they can change, for example, the target quality as well, depending on whether quality is more important or the bandwidth reduction is more important for them.
And how are you working with HDR?
We don't handle HDR especially. Like I say, what we try to do is to target for higher VMAT score instead of trying to fine-tune all the parameters.
So if I'm working with 10-bit footage that's HDR in, you're going to just optimize the bit rate and then send out the HDR string as before, or whatever HDR parameters are in the file.
Exactly.
Okay, that's all I have. Listen, thanks for joining me today.
Thank you. It's a pleasure. And please come to our booth at NME. We have a lot of demos and new announcements to share with you.